Hello boys and girls, Mr. Giomini wanted to come to you with two different algorithms for finding the GCF and LCM of two or more numbers. The first algorithm I'll use that I've used in class deals with prime factorization. And to deal with prime factorization, it's important I know the factors of numbers. So let's take 36 and 45. Now in my head, I know that 36 is 6 times 6, but I also know that neither of those numbers are prime. So I need to break 6. We have 6 times 6 is 36. Well, we know that both of these are not prime. We know that 6 is 2 times 3. And then we also know that 6 is 2 times 3. Going with 45, I know that 45 is 9 times 5. I know that 5 is prime. I know that 9 is not. 9 is 3 times 3 as a product of prime numbers, and I multiply by 5. Now remember with GCF, we're looking for common factor pairs. This is one pair of factors that are common. They both have 3's. They both have another 3. Now remember with GCF, we don't worry about the leftovers. We will cross those out so we don't get confused. Recall a pair of 3's. A pair of 3's is then 1 3 times another pair of 3's, which is another 3. 3 times 3 gives me 9. This is one algorithm using prime factorization. The other algorithm does something similar. It looks like an upside down division symbol. And I will put 36 and 45, if you want to think about it, sitting on the shelf there. We'll do something similar. I am now going to say, what's the greatest common factor of 36 and 45? Now again, it's important we are fluent with the multiplication facts. Because I am somewhat fluent, I know that it is 9. Now 9 times 6, or excuse me, what times 9 is 36, or 36 divided by 9 gives me 4. 45 divided by 9 gives me 5. Now, neither of these numbers have a common factor. 4 and 5 share no common factor, so I am done. I will cross out the numbers that are below the division line, and I will just circle this. That tells me that their GCF is also 9. So this is the other algorithm that I can use. It's almost like upside down division if you want to think about it that way. So the GCF using this algorithm is 9. The GCF using prime factorization is also 9. This one I'm using essentially their greatest common factor right off the bat, or at least a common factor for both. Here I'm using prime factorization. Same method could be used for doing LCM, or similar algorithms I should say. So to find the LCM of 24 and 32, I will list the factors, the prime factorization of 24. Now I know 24 is 8 times 3. 8 is not prime. 8 as a prime number is 2 times 2 times 2. There's a prime factor string for 8. I will multiply that by 3. 2 times 2 times 2 is 8, times 3 is 24. Let's go 32. I believe 32 is 4 times 8. Well, 4 is 2 times 2. And 8, as we just discussed, is 2 times 2 times 2. Now, similar to GCF's algorithm, I will now combine common factor pairs. So there's a factor pair, there's a factor pair, there's a factor pair. I have 1, 2, 3, 2. So 2 times 2 times 2. Now with LCM, we need to use the leftovers. We need to use leftovers. So now these leftovers, those 2 2's come, and that 3 comes. Now that's a lot of numbers to multiply. Well, I know that 2 times 2 times 2 is 8. So I will chunk that together. That gives me 8. 2 times 2 is 4. 4 times 3 gives me 12. So I have 12 times 8. That tells me the LCM, least common multiple, for this is 96. I will also use this division method to find the LCM. And let's see if it gives me something similar. 36. 45. Now, I like to find the biggest factor that they both have in common. In this situation, I'm doing the numbers up top. I need to do 24 and 32. Excuse me. 24 and 32. 24, 32. Now, I believe that the largest number that goes into both is, and let's say I don't choose 8 because that's what it is. Let's say I choose 4. Okay, so I choose 4. How many times does 4 go into 24? It goes in 6 times. How many times does 4 go into 32? That goes 8 times. Now, let's try and find a factor that goes both into 6 and 8. And I said it is 2. Now 2 goes into 6 3 times. Let me use another color real quick. 2 goes into 6 3 times. 2 goes into 8 4 times. Now I've noticed that this one can no longer be simplified. It already is a prime number. I'm going to leave that alone, but 4 is not a prime number. This is where it changes slightly. So I'm going to draw that another division line. I know that the largest factor of 4 besides 4 is 2 I could put. I wonder if I could put a 4 there, because the largest factor of 4 is 4. Let's try that. Let's see what happens. Now, obviously this just becomes a 3. This would become a 1. Now what I do, when I did GCF, I just multiply the numbers on the outside to the left. Here, I multiply all these numbers that essentially surround the division bars. So let's break this up. 4 times 4 is 16. 16 times 2 is 32. 32 times 3, and then times 1 I could ignore because we know it's going to be itself. Look at that. It gives me 96. So it also gives me the LCM of 24 and 32 being 96. So there is a second algorithm that you can use to help you with GCF and LCM. Take care.